Hi students, let's take a look at your worksheet that you completed on probability of simple, independent, and dependent events. Number 1, Kenya is trying to find matching socks. There are 4 red socks, 6 blue socks, and 2 white socks in her drawer. What is the probability that Kenya will pull out a blue sock, put it on, and then pull out another blue sock to put on? So for this one, we're first going to try to figure out, is this going to be an independent, dependent, or simple event? So if we look here, we can see that this is a dependent event. So we're going to circle dependent. And it is dependent because she is putting the sock on. Because she's putting the sock on, that means she's not replacing it. And that's going to have an impact on our answer. Not, oops, replaced. So looking at our notes from yesterday, we can figure this out. So the first thing we need to know, we have 2 events. So we want the probability of a blue sock and then another blue sock. So if we look at what we have 4 plus 6 plus 2, we have 12 socks. And out of those socks, 6 are blue. So 6 out of 12 are blue. So that's our first event. Our second event, now we have taken 1 blue sock out, so there are only 11 socks. And because one of them we're assuming is blue, we now only have 5 blue socks. So to find the compound probability, we're going to multiply those 2 fractions together. You can see here that we can simplify 6/12 into 1/2. We multiply across and we get 5/22. So the probability, it's dependent, and the probability of Kenya choosing a blue sock and then another blue sock would be 5/22. The second problem, what's the probability of rolling a 4 on a number cube? All right, for this problem, you can see there's only one event that's happening. So since there's only one event, we're going to say this is a simple event. And rolling a 4, if we have a number cube with 6 numbers, there's only one 4. So the probability of a 4 is going to be 1 out of 6. So that's a simple event, and the probability is 1 out of 6. Number 3, we're going to find the probability of pulling out a letter S. So the probability of pulling an S or pulling S is going to be equal to the number of S's that are there. So we have 2, 4 S's. And with the word Mississippi, we have 2, 4, 6, 8, 10, 11. So out of the 11 letters, 4 of them are S's. There's only one event. So this is a simple event, and it's 4 out of 11. Number 4, your favorite flavor of gum is green apple. So that's what we're looking for. The gumball machine contains 10 grape gumballs, 12 strawberry gumballs, 3 lemon gumballs, and 10 green apple gumballs. What is the probability that you will not, that's really important, that you will not get your favorite gumball from the machine? So our probability is not green apple. And for this one, we're just looking at one event, one thing happening. So again, this is simple. And for the probability, this is theoretical probability of getting a gumball that's not green apple. So for this, we need to figure out how many gumballs are not green apple, and then we need to look at the total number of gumballs. So for this, not green apple would be 10 grape, 12 strawberry, and 3 lemon. So we have 10 plus 12, which is 22, plus 3 would be 25. And then if we add the other 10 that are the green gumballs, green apple gumballs, we get 35. So 25 out of those 35 gumballs are not green apples, so we can use our probability by looking at our favorable event, which is not green apple, out of our total number of gumballs, which is 25/35. We're going to simplify this by dividing our numerator and our denominator by 5, and I get 5 out of 7. So it's really important that you take a look at this word not. All right, moving on to number 5. What is the probability of rolling a 4 on a number cube and, so we've got an and here, pulling a red marble out of a bag that contains 3 red, 2 black, and 5 yellow marbles? So as you can see here, we have 2 events. So we've got rolling a 4 on a number cube and pulling a red marble. So we're looking for the probability of getting a 4 and then pulling a red marble. Now this is 2 different events, so it's either going to be independent or dependent. So we got to think, does the second event, pulling a red marble, is that impacted at all from what we get on the first event? And you can see that it does not. It's not impacted because no matter what we get on the number cube, we can get any possible color out of the bag. So this is going to be an independent. The second event is independent of the first. So rolling a 4 on a number cube, we have 1 out of 6 of the sides are 4s. And we're going to multiply that by the number of red marbles that we have. There are 3 red. And then the total would be 3 plus 2 is 5, plus 5 is 10. So we simply multiply these 2 together, and the probability of rolling a 4 and pulling a red marble would be 1 times 3, which is 3, and 6 times 10, which is 60. And then we need to make sure we simplify this. 3 goes into 3 once. 3 goes into 60. 20 times. So our answer here is 1 over 20. So that's the probability of 2 independent events. Number 6, a deck of playing cards contains 52 cards. What is the probability of pulling out a king of diamonds and without replacing it, then an ace of spades? Okay, so for this you've got to think about a deck of cards. We have 2 different events. So we know it's not going to be simple. We're not replacing it. So that means once we take out that king of diamonds, it changes the deck of cards that we have. So it's going to change. The ace of spades, the probability of getting ace of spades is changed by whatever you pull out first. So this is actually going to be a dependent event. All right, so we're looking for the probability of a king of diamonds and then an ace of spades. All right, so the king of diamonds, there's only 1 king of diamonds and a deck of 52 cards. And an ace of spades, there's only 1 ace of spades, but once we take out the king of diamonds here, you have 1 less card. So instead of 52 cards, I now have 51 cards, in which there's only 1 ace of spades. Okay, so that's the difference between independent, like we have in number 5, and dependent in number 6. We only have 1 card that's of each, but we change our denominator from 52 to 51 because this is a dependent event. And when we select the king of diamonds, we leave it out. And then we have a king of spades. So a key word here for determining whether it's an independent or dependent event would be without replacing it. Now we're simply going to multiply those numbers together. And we get 1 over. We're going to multiply 52 times 51. And we get 2,652, so it's not very likely. 2,652. All right, number 7, Diamond is playing a game. In the game, she has to spin a spinner that's divided into equal sections of orange, red, purple, and pink. What is the probability that her first spin, she will land on pink, and then red on her second spin? So again, we have 2 spins here. We have a first spin and we have a second spin, so we can go ahead and cross out. This is not a simple event, so it's either going to be independent or dependent. So at this point you need to think, does the second spin depend on the first spin? So if I get an orange, for example, or a pink, is that going to make it more or less likely or the same likely that I'll get a red on the second? Well, the second event is not impacted by the first. So this is going to actually be an independent event. So we're looking for the probability of getting a pink, then a red. All right, so the probability of pink is going to be 1 out of 4 because we have 4 different sections, 1, 2, 3, 4, one of which being pink. We're going to multiply that by the 1 out of 4 sections that's red. So that means we have a 1 out of 16 chance that the spinner will land on pink and then red. So again, this is independent. The second event is not impacted by whatever happens for the first. All right, let's keep going. Number 8. So now we have numbers 1 to 20 placed in a bag without replacing. So ladies, this is key. It's without replacing the first number. So we're not replacing. So what that means is this is going to be a dependent event because when we take one number out, now what we have available to us is change, and that's going to impact our second event. All right, so we have 1 through 20, so that's 20 numbers, and we're looking for the probability of getting an odd number and then getting an even number. So the probability of getting an odd number, we know for the numbers 1 through 20, half of the numbers, every other number is odd, every other number is even. So half of the numbers are going to be odd. So that's our first event. We have a 1 out of 2 chance of selecting an odd number. Now for our second event, because this is dependent, we don't have 20 numbers anymore. The second event is dependent on what happens in the first because we're not replacing. So our second number, we now only have 19 tiles or 19 numbers remaining in the bag. And since we've taken out an odd, so we had 10 out of 20, which is our 1/2. This 1/2 is our 10 out of 20. So our 10 out of 20, now we only have 19, right? So we've taken out one number, one of the odd numbers, but we still have the same number of evens. So the number on top is going to be a 10 because we took out one of the numbers that's odd. We still have 10 out of 19 numbers that are even remaining. So we're going to multiply these together and we get 10 and then out of 38. Okay, we can simplify this to 5 out of 19. So hopefully you guys are seeing the difference between independent and dependent. So with dependent, we're not replacing. With independent, the second event is not impacted by the first. So let's move on to number 9. On a shelf, there are 60 novels and 20 poetry books. What is the probability that person A chooses a novel and walks away with it, and then person B walks up shortly after and picks another novel? All right, so we've got 2 events. We're going to eliminate simple. So this is either going to be independent or dependent. So let's look at the problem. Probability that person A chooses a novel and she walks away with it. So once that person A walks away with a novel, there are fewer novels to pick for person B. So this is actually going to be another dependent event. So because it's dependent, that second one's going to change, and we'll talk about that in a second. So we're looking for the probability of the selection of a novel. We're not replacing it, and then another novel. So the probability of the first novel is going to be 60 out of 80, right? So that's going to be 6 out of 8, which simplifies to 3/4, right? So 60 out of 80 is going to be 3/4. That's our first novel. The second novel, however, we only have 79 books left, right? Because we had 80, now we have 79. We've taken one novel. Person A has selected one novel. Instead of 60, we now have 59 novels to select, and that's why it's dependent. So we're going to multiply these together. I'm going to multiply 59 times 3. Which is 177, and then 4 times 79, which is 316. All right, so that is our probability. The probability of getting a novel and then another novel, it's dependent, and it's 177 out of 316 chances. All right, moving on to number 10. In a classroom, there are 100 students, of whom 40 are boys, 30 of the 100 students wear glasses, and 15 are boys who wear glasses. If one student from the class is randomly selected, what is the probability that the student will be a girl who does not wear glasses? So we know how many are boys, we know how many are students that wear glasses, and how many are boys who wear glasses. So for this one, ladies, I'm going to go ahead and wait. We're going to look at this one when I get back. This is going to take a little time to discuss. So we're going to look at number 10 tomorrow. Let's move on to number 11. Number 11, 2 cards are drawn from a single deck of 52 cards, one after the other. So we know it's not simple. We've got 2 cards. The first card is not replaced. Okay, so that's important too. Not replaced. We're going to find the probability of getting a king and then a queen. All right, so the probability of a king and then a queen. So for the king, hopefully you guys know that in a deck of cards we have 4 kings. So 4 out of those 52 cards are kings. So we can simplify that. We can divide both of those numbers by 4. 13. So this can be simplified to 1 over 13. So that's the probability, because there's 4 out of 52 cards are kings. We have a 1 out of 13 chance of selecting a king on the first one. And a queen. It's not replaced. So hopefully you guys can see that this is going to be dependent. It's not replaced. So I'm going to multiply this by, and again, I have 4 queens in the deck. I've taken out a king on my first. That's what I'm assuming. I'm probability of selecting a king. My second draw, I still have 4 queens, but instead of 52 cards, I only have 51 because I've taken one out. So I'm going to multiply across. 1 times 4 is 4, and then 13 times 51. And I get 663. So very slim chance of that happening. It's a 4 out of 663 chances that I would draw a king and then a queen out of that deck of cards. Number 12. 10 cards are numbered from 1 through 10. The cards are drawn at random. If 2 cards are drawn with replacement, find the probability of choosing a prime number in both the first and the second draw. All right, so what I'm going to do for this one, we need to look at our numbers 1 through 10. And remember, prime numbers have exactly 2 factors, 1 in themselves. So I'm going to circle 2 is prime, 3 is prime, 5 is prime, 7 is prime, and that's it. The other numbers are the opposite of prime, which is composite. So out of the numbers 1 through 10, we only have 4 that are prime. And again, if you look in our problem, this is with replacement. So that means we're going to put the card back in. We're going to draw a card, we're going to put it back in, and then draw another card. So this is going to be independent. Because we're putting that card back in, the second draw is not dependent on the first. So we're looking for the probability of drawing a prime number, and then another prime number. And this is independent. So we have 1, 2, 3, 4. We have 4 out of our 10 cards are prime. And then the second draw, because we put it back in, we still have 4 out of 10. But check it out. We're going to simplify. We're going to make those numbers smaller, or the fractions are still the same quantity, but the numbers that they represent are smaller. So 4/10 is the same as 2/5. 2/5. And then we're going to multiply across. 2 times 2 is 4. 5 times 5 is 25. So the probability of getting a prime and then another prime number without replacement, or with replacement, excuse me, is going to be 4/25. All right. Number 13, what is the probability of getting a 7? So rolling 7. It's just one event. Okay, it's just one event. But it's after rolling a single number cube, number 1 to 6. So we'll assume we've already rolled it, but we're just trying to find the probability of getting a 7 one time. So this is going to be simple. And hopefully you guys figured this out. There are no 7s on a number cube numbered 1 to 6. So our probability is going to be 0/6, or just 0. Number 14. We're looking for the probability of landing on heads when tossing a coin and rolling a 6 when rolling a number cube. Okay, we have two separate things. We have a coin and we have a number cube. The number cube is not going to be impacted by what the coin is. So this is going to be independent. And then the probability of landing heads, and then rolling a 6. So on a coin, we know the theoretical probability for heads is 1 out of 2. And then the probability of rolling a 6 on a number cube is going to be 1 out of 6. So we simply multiply those two together and we get a 1 out of 12 chance. All right, finally, the last one, probably the easiest question. We're looking for the probability of landing on heads when tossing a coin. So this is going to be a simple, right? We only have 1, and we have heads or tails. We have either heads or tails, so this is going to be a 1 out of 2. So our probability is 1 out of 2. All right, that's it. Make sure you take this home with you so that you can review it when you do the next assignment.